Hello everyone, today let's solve the problem number 295. Find median from the data stream, right? So what the question states here, we need to implement a median finder. You can clearly see here, we need to implement a median finder class. So this one I'm speaking of class median finder. So see, sorry, this one. We need to implement a median finder class that maintains a stream of numbers. It maintains a stream of numbers basically and efficiently finds the median. So we have to efficiently find the median as well. So just keep this in mind. The median is nothing but the middle value in the sorted list. So the list is already sorted. The median is nothing but the middle value in the sorted list they have given, right? If the list has even number of elements, then the median is average of two middle values. So if it is even number, then it is the, if the list has even number of elements, then the median is average number of two middle values. So it's just the average of two middle values if it is even, right? If it is odd, we will get the mid value directly, right? So if it is even, then the median is the average of two middle values. So operations include add num and find median. You can clearly see this one, add num and find median. This is the initialization part, median finder. So add num and find median. Always just remember this one. So the return value of the add num and median finder is null, right? So only the return value of the find median is number, right? So just keep this in mind. These two, however, will be performing these operations, but the return value is always null. So this is the initialization part, and this is just, but we are just adding the number. We are not returning anything for the add num function. Just remember this one, right? So they have clearly mentioned the same thing here. You can just go through this one as well. So in this case, we have operations include add num nothing but here this one I'm speaking of, add num int of number we have as parameter, right? So this adds an integer to the data structure. We are just adding the integer to the data structure. We are not returning anything. And find median here in this case, this one I'm speaking of, find median, right? So find median here, this returns the median of all the elements that has been seen so far, right? So this returns the median of all the elements that has been seen so far. Means return value is number for this case. Just keep this in mind. So let's come to the first example here. We have, just give me a second here, just a second. Yeah, we have median finder, this one function, add num, median finder, add num, find median. So first thing is median finder of this one empty we have. Yeah, this one will be considering this one itself, empty itself, right? So we'll be considering here in this case. So median finder of empty this one array will be null itself. For this initialization part, the return value is null. I have already set this one, right? This is fine. So that is how we got null here in this case. So 1, add num of 1. We are adding the value 1 right here. Still we have added successfully, we have added the number 1, but still the return value is null for the add num. We don't have to return anything. We just have to add the number, right? So this is fine. Next, let's go with the this one 2. We will be adding the number 2, but still here in this case we are just adding, we are making use of the add num function here, right? So the return value is still null. Now we have 1 and 2, right? So now we have 1 and 2. As we have added 1 and 2, so basically the approach that we'll be making use of here is priority queue, min and max priority queue, right? Or min heap and max heap, or you can just consider min and max priority queue. Just keep this in mind. Basically now we have 1 and 2, right? So now we have 1 and 2 we have added, right? So now next let's go with the find median here. Find median, the return value is number for this function, right? So the return value is number. Now we have two numbers, so this is even, right? So this is even. So this is nothing but when we have even number, I have said that if the list has the even number of elements, the median is average of the two middle elements. In this case, it will be 1 plus 2 by 2, right? So that's what they have shown here, 1 plus 2 by 2, nothing but 3 by 2. 3 by 2 is 1.5. We need to return 1.5 in this case, right? So the output will be 1.5. Next, now we have 1.5 for the first median, this one. So add number again. So the return value is this one, null. So we are adding 3. Now we have, instead of 1 and, we had only 1 and 2 previously. Now we have the numbers 1, 2 and 3, right? So now we have the numbers 1, this one, 2 and 3. Previously we had only 1 and 2. So when we were finding the median, it was 1 plus 2 by 2, right? So now we have 1, 2, 3. Here we have add num of 3, right? So now we have number 1, 2, and 3. The last one is find median of this one empty. So this one empty array they have given. Now we have 1, 2, and 3. When we need to find median here, 1, 2, and 3. So middle number is the median, this one, right? So this itself we can directly consider. This one will be 2.0. Nothing but 1 plus 2 plus 3 in this case, 6 by 3. This becomes basically 6 by 3. When we this one calculate, this one will be 2.0, or you can just go with the middle element. That also works, 2.0 in this case, right? So I hope this is clear, right? I hope this is clear. Output, how we got output is completely clear, right? So they have clearly mentioned in the explanation. You can just go through that one as well. So same thing, similar thing, I have explained the how we got the output by considering the first example, right? So let's discuss the approach first. Now this one, I hope the question is completely clear. What we need to do is completely clear as well. Now let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the. So first thing that we need to keep in mind here is we will be making use of the 2 priority queues, right? So we'll be making use of 2 priority queue. Nothing but here in this case, I'll be making use of min priority queue and the max priority queue. Or you can consider we'll be making use of 2 heaps. We'll be going with min heap and the max heap. Or you can just call this one. We'll be making use of 2 priority queue, min PQ and max priority queue. This is fine. So the same first example that they have given in the question, I have considered the same thing that it will be, so that it will be easier to understand, right? So we need to get this output, right? So let's discuss, we have already discussed this one. Let's discuss the step-by-step execution, right? So the first step here, so we are going with the left half and the right half. So we are going with the left half and right half, right? So we are going with 2 priority queue. Just keep this in mind. So one is min priority queue and max priority queue. So we are making use of both here in this case, right? So we are making use of min priority queue as well as the max priority queue. 2 priority queues will be making use of. So first thing, initial state, we will be initializing left half to empty array and the right half to empty array. So first, the second step, this one I'm speaking of. First, median finder, initialization part, left half and right half. So the output will be null in this case. So the output will be null in this case because the return value, initialization part, right? The return value is null. So let's move on to the next one, add num of 1. This one we are considering here in this case, add num of 1, right? So here in this case, we are adding, inserting 1 into the left half, or we are adding 1 into the left half. Now the left half becomes 1, right half remains same, empty, right? So now we have inserted 1 into the left half, right? So still the return value of add num is null. We have to return null in this case. Now we have 1, but we have to return null in this case. This is fine. So let's move on to the next step here. So add num of 2. So this I am considering the next one. Add num here, add num of 2 here in this case, right? So add num of 2 is nothing but null here again. Why? Because we are inserting 2 into the right half. The left half already has 1 from the previous step, and we are just inserting 2 to the this one, right half. Now we have 1 comma 2, right? So now we have 1 and 2. Now we have inserted 1 and 2 to the priority queue, right? So now we have inserted 1 and 2 to the priority queue, right? So this is fine. So still the return value is still null because the return value of add num is still null. Only the return value of find median is number. We have discussed this one several times. Just keep that in mind. So find median. So add num of 2, still this is null itself. Let's move on with the find median now. Find median of this one. Empty braces they have given. So we have to find the median, right? So this is even size list because we have 1 and 2. So 2 is even, right? So in that case, we have to find the this one. Basically, I have read this one multiple times. If the list has the even number of elements, the median is the average of 2 middle elements. Nothing but we have only 2 elements, nothing but 1 plus 2 by 2. This will be basically 3 by 2, nothing but 1.5. So we have got 1.5 here in this case. So this is 1.5. This is same as this one, right? This is 1.5. We have to return 1.5 because find median, this one, what do we call that one? Just give me a second here. The return value of the find median is number. So in this case, we are returning 1.5. This is fine. So let's move on with the add number again. So add number return value is null. So we are inserting 3, the next element we are going with, right? So here in this case, they have asked us to add number of 3 here. You can clearly see we are adding certain integer here. We are adding the integer 3 here into the right half. But balance helps here, right? So left half consists of 1 and 2 now. So 2 was in the right half basically. So 1 and 2 will be moved to the, that's what I have written here. But the balance helps here means 2, the priority queue, max priority queue, 2 comes first here, 1 next, 2, 1, this one comes first, and we are adding 3 to the priority queue, right? We are adding 3 to the priority queue. In this case, we have 2 comma 1 in the left half and 3 in the right half, right? So now we have basically in simple terms we have 1 comma 2 comma 3 in the priority queue, right? So we have inserted 1 comma 2 comma 3, but still for this step the return value is null. The return value of add num is null. We will return null in this case, right? So we will return null in this case. This is fine. So let's move on with the final step here, find median. So let me come here, find median of this one empty. Basically find median, we have to find the median in the array. It shouldn't be having we shouldn't be having any value right here. So this is odd sized list because 1 2 3 we have inserted the numbers 1 2 3 into the priority queue. This is odd list. Whenever we are having the odd list, we will be considering the middle element, right? So this will be 2.0. So this will be 2.0, or you can just add these things 3 2 3 4 5 6. When we sum up this one 6, we will get total number of elements we have is 3. You can divide this one, then also you'll get 2.0 in this case. So you can do that one as well to find the median. This is fine. Middle element in the left of is 2.0. We'll consider directly this one as I've said, right? So 2.0. So this one 2 will be the output. So here just give me a second here. In this case we have got 2.2. This is how we got the output basically, right? So this is the approach that we'll be going with. Easy, right? 2 priority queues we have made use of. One is min and one is max in this case. So you'll understand when we try to implement our thought process in the form of code. When we write the code, you'll understand this one crystal clearly. I bet this one, right? So this is fine. Let's move on with the edge cases. First edge case is for the single element here. In this case, input is 1, the output is 1.0 because we have only single element here. The output will be 1.0. So this one we are considering for the find median every time, right? So we are not going with the initialization part or the this one add num. We are considering only find median function here, right? For all the edge cases here. For the even elements, so this is for the second edge case is for the even elements 1 by 1 comma 2. We have already seen this one. The output will be 1.5, right? 1 plus 2 by 2. So this will be 1.5. So basically this one we have only one element. We'll directly consider one itself, right? So this is fine. So let's move on with the third edge case. We have all elements same. All elements same we have. See here. All elements same here in this case, right? So here all the elements are the same. So the median remains same here, 5.0. Just remember this one. All elements are same. So median remains quite obviously 5.0. So same, right? So in this case, let's move on with the fourth edge case here, odd elements. We have odd elements here. 3 elements we have here, right? 3 elements, nothing but we have odd elements in this case, right? So this one output is 2.0. Why? Because the middle element is 2 in this case. So here odd. This one we will consider middle these 2 elements. So this will be 5 plus 5 by 2. So this becomes 10 by 2 and 5.0. This is fine, right? So this is middle element directly we will consider. This will be 2.0 because this is odd. This is fine. So let's move on with the final edge case here, alternating high low numbers. Input 10 1 9 2 8 we have here. 10 1 9 2 8. So this is odd, right? So here in this case we will consider, so here we have the elements 10 1 9 2 8. The median will be 8.0 because they have clearly mentioned in the question they'll always give this one input in the sorted order, right? So when we sort this one we get 1 2 8 9 10. So this is odd, right? So we have odd number of elements here, 5 elements we have total, right? So we'll consider the middle element. In this case it will be 8.0. This is fine. So these are the edge cases that we need to consider here, right? So these are the edge cases that we need to consider here. The first edge case is for the single element, the second edge case is for the even elements, so the third edge case is for the all elements same, the fourth edge case is for the odd elements, the fifth edge cases for the alternating high-low numbers. So I hope all the edge cases are completely clear. So these are the edge cases that we need to keep in mind. Now we are completely familiar with the edge cases as well as the approach. We are good to write the code. Let's start writing the. So the first step here, as I have said, we will be making use of the minimum priority queue as well as the maximum priority queue. Let's initialize the max priority queue as well as min priority queue. Max priority queue for the smaller numbers and minimum priority queue for the larger numbers. So I'll just come here before the median finder function. So this one I'll just initialize here private. So let me go with priority queue here. This one type integer. So this one we'll be considering this one as left half. We have already discussed this one in the approach, right? So let me consider the same thing and make the necessary changes for the min heap as well. So this one will be, instead of left, I'll just consider here right half. So this is for the, this is nothing but min heap. The line number 3 is max heap. The line number 4 is min heap, right? So I hope this is clear. The next step here is we'll be making use of the max priority queue, right? So I'll just come here within the median finder. So left half, this one I'll just initialize here new priority queue here. This one I'll just go with collections dot reverse order. This is fine. So let me make this C capital. So collections dot reverse order. So this is fine. So just we are making use of the max priority queue here, right? So next we have to make use of the min priority queue. So for the right half, so I'll just give here right half. We are just initializing max and min priority queue here. We have given priority queue this one left half and right half. Same thing, we are initializing the same thing within the median finder function, right? So I'll just go with, let me copy this one priority queue here. So let me give priority queue here. This is fine. So the line number 7 is max priority queue. The line number 8 is min priority queue. We have initialization. We are done with the initialization part. Next, let's move on with the add num function, right? So first thing, we have to insert into the max priority queue if the number is smaller, right? So if the number is smaller, we have to insert that into the max priority queue. If the number is larger, then we have to insert the number to the minimum priority queue. That's what we need to implement the same thing in the form of code. So simple if condition here, if, so here left half, this is for if number is smaller, we are inserting into the max priority queue here in this case, right? So this one, if it is empty, is empty, this function, right? So this is fine. Or num less than or equal to left half dot peak here in this case. So peak, right? So sorry, this is fine. Then what we will do, we have to insert into the max priority queue. So for that one, left half. So for adding or for the insertion, we'll be making use of the property offer, right? So for this one, for removing, we'll be making use of the poll, and for adding, we'll be making use of offer. We know this one, right? So I'll just go with offer of num in this case. So this is fine. So else, what we will do here in this case, else if the number is larger, then we have to insert or add the number into the minimum priority queue. So I'll just go with, let me copy the same thing, man, and let me make the necessary changes here. So I'll just paste the same thing over here. So instead of the left half, this will be considered as right half. This is fine. Right half dot offer of num, same thing, right? So if the number is larger, so we have inserted into the max priority queue if the number is smaller. We have inserted into the min priority queue if the number is larger. These two things, I hope this is clear. So next, we have to balance the priority queues. So their sizes differ by at most 1. We have done this one during the last step. During the last step, if you remember, so that the balance we gave, and we have inserted 2 comma 1, right? So we had inserted 2 comma 1, if you remember in the example. In the approach I showed the same by considering the first example. If you have followed the approach correctly, you will be knowing. So now we have to balance the priority queues so that the sizes differ by at most 1 here in this case. So if left half dot size here, this one, if it is greater than right half size here, so this is fine. Then what we will do, we will move top from left to right. So we will move top from left to right. This will be right half so we are adding this one, right? So I have to make use of the property offer here. So just give me a second here. This will be left half. So within this one we are removing. So we are moving top from left to right, right? So we need to remove the this one element in the left half. For this one, left half dot pole I'll be making use of, right? So next same thing, but we will move top from right to left, right? So I'll just copy the same thing here and make the necessary changes here. So I'll just come here. So I'll just give here else and let me copy the same thing here. So here else if instead of the left half, let me make this one as right half. This is fine. Right half dot size, if it is greater than, not right half, this one, this will be left half dot size. Then what happens here, then we will move the top from right to left. This will be instead of the left half, it will be instead of the right half, it will be left half, because here we are considering for if left half, size of the left half is greater than size of the left half, right? So here in this case we are moving top from right to left. Left half dot offer we are adding, this is same. We have to remove the right half, right? So we have to make use of the pole property with the right half, not the left here for this case. So this is it for the this one add num function, right? Simple to understand. We went step by step. So the next step here is we have to find the median, right? So this is the calculation part basically. Even case and the odd case we need to consider. So the last one, we have to find the median and we have to return the number. The return value is number. We have discussed this one multiple times. Just we have to only focus on the calculation part within the find median, right? So simple if condition here, if, so let me consider here left half here in this case, size of the left half here, if it is equal to, so here right half, so let me copy this one here, right half. So if it is equal to size of the right half, if the left half, size of the left half is equal to size of the right half, then what we need to do here, even case. In the even case, we have to consider two elements, the mid two elements, and we have to divide the elements by 2, right? So I have to just implement the same thing in the form of code here, return. So again, so this one will be return left half dot peak. Peak is nothing but front, right? So this one plus right half. Again, we'll be making use of peak itself, as we are dealing with a queue, right? So this one peak, right half peak here, this one by 2. So we'll divide the two numbers, mid two numbers by 2 if it is even. So I'll just comment this one. If you didn't understand, this is for the even case, right? So this is fine. What if it is odd? We will return the mid element. If it is odd, we'll directly return the mid element, right? So I'll just go with return this one left half. So let me copy the entire thing here, left half dot peak here in this case, right? So this is for odd case, this is for the odd case. Let me format the code once, right? Let me format the code once and let me hit the run button. So line number 13, I have just given is empty here. Where So here left half I have made use of. This one is within the add num function, right? So this one left half dot is empty. It has to be. So here why did I give only dot here? So if left half is empty, or if number is greater than the left half dot p, right? So then only we are inserting the number into the maximum priority queue. Means if the number is smaller, basically, right? So this part I forgot to type left half. I think this is fine. Let me hit the run button now. I hope this works, man. Let's see. Again we have here right of this h has to be capital, basically, where line number 19. So let me come to the line number 19 here. So here let me make this h capital, basically. So let me hit the run button again. Line number 21 now again. Oh yeah, h capital again. Let me hit the run button. So many typos. Wrong answer. So what is wrong here, basically? Null 2.0. Just a second. 2.0 we are getting. So this has to be 1.5. Instead we are getting 2. This is fine. Here we have to get this one 2.0. We are getting 3.00. So let's see what is wrong here. So somewhere calculate. So what mistake I have done here is in the line number 7 within the initialization part in the median finder function. Within the median finder function we have already initialized the left off here. So I don't know why I have done the same thing within the add num. This is not needed, basically. So let me remove this one. So now let me format the code once and let me hit the run button. So I hope this works. Let's see. Again we are getting the wrong answer. What we are getting here? 1.5. This is fine. Instead of 2 we are getting 1. So let's check what. So what mistake I have done here is we are getting 2.0 here in this case, right? So we are getting 2.0. So this one when it is odd, right? So this one when it is even. So we are, for the even we are getting correct. But for the odd we just have to consider only the middle element here, in this case +1, because we are considering 2 elements when it is even, right? So then we are dividing that one by 2. So in this case we have to just consider the middle element, right? So the +1 is not needed here in this case, right? So the +1 is not needed in this case. So let me hit the run button. Let's see whether this works. I hope this works, man. Let's see. Yeah, now you can clearly see the sample test case is getting passed. Means let me hit the submit button quickly. So I hope this works for all the cases. Let's see. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case. So there were some typos, and this one mainly, basically in the line number 20 here, no need of +1, right? So that's the reason we were getting the wrong calculations, right? So this is fine. So now all the test cases are getting passed, right? Means the code works absolutely correct in this case. Now we are good to discuss the complexities for the code that we have written, right? So first thing that we need to remember here is the approach that we went with here is 2 priority queues or 2 heaps, 2 priority queues, right? So min priority queue as well as the max priority queue. We know this one. So we have implemented the same thing in the code. So overall time complexity here would be for the add num function, it would be big of logarithmic n. For the add num function, it would be big of logarithmic n, right? So I'll just write here for the add num function, it is big O of log n. So why it is big of log n? Basically, we are performing the heap insertions and we are balancing it, right? So that is the reason it is we are making use of the priority queue, right? So due to the priority queue insertions and balancing, overall time complexity of the add num function is big O of logarithmic n. So I'll just give here time complexity. The first one here, add num is logarithmic n. This is fine. So let's come to the second part. So for this one, what do we call? For the find median function. So the time complexity for the find median function is big O of 1. Why it is big O of 1? Because we are making use of the priority queue. Means we are making use of the top access within the priority queue, right? So we are making use of the top access within the priority queue. So overall time complexity, which is basically constant time, which requires basically constant time, right? So overall time complexity would be big of 1 in this case. So overall time complexity would be big of 1 in this case. So the time complexity would be big of overall time complexity of the find median function would be big of 1, right? So I hope this is clear. This is fine. Let's move on with the space complexity here. What would be the overall space complexity here? Overall space complexity remains big of n itself. Why? Because we are storing all the numbers in the priority queues. So we are storing all the numbers, right, in the priority queue. Each number we are storing all the numbers. So when I say all the numbers here, we are adding this one first. Here in this case, in the first example, we have added one. We are storing that one in the memory. We have added 2. We are storing that one in the memory. We have added 3. We have stored that one in the memory as well. So we are adding or we are storing all the numbers in the priority queue. So overall space complexity would be quite obviously because of n in this case, right? So the time complexity, so just give me a second here. Yeah, the time complexity of the add num function is big of logarithmic n, and the find median function is big of 1, and the space complexity is big of n for the code that we have written. I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.